But there's a 3 somewhere.
Okay, so remember, I said,
You see where I'm coming from?
I know exactly where you're going. I know exactly where you're going. The idea was to see something and its derivative, right?
Exactly.
Okay, we see something, here's its derivative. Do we see this? Not quite, right? We don't have 2x plus 3, do we? What do we have? 6x plus 9. But I can make this 6x plus 9 by doing what? Multiplying both sides by 3. I'm off by a multiple. Do y'all see that? I'm off by a multiple. I can multiply 3 here and 3 here. If I do that, then this becomes 3 du equals what? 6x plus 9 dx. And now, now I'm in business. That matches this, right? That and that together. I'm grouping those together because remember that 6x plus 9 can slide out, can't it? If you like puzzles, this is going to be your deal right here. And the great news, if there is great news right now, is that all the problems you do will work with the substitution. You just have to get the right substitution, do what you need to do to make things match up, and then plug in and you're there. It becomes difficult, y'all listening? It becomes difficult in Cal 2 when you have 5 different methods that you've learned and someone throws an integral at you and says, do it. And you don't know what to do. You don't know if it's substitution, integration by parts, trig sub, partial fraction. You don't know what it is. And it's the repetition and you doing hundreds of problems on your own that makes you good at seeing it and knowing what to do. It's got to be practice. Yes?
So once you identify the thought you do, don't you just replace 3D?
Yeah, you ready to plug everything in? Yeah, I'm ready. I'm not done. Yes?
So kind of what you're talking about where there's like 5 methods and they give you an integral and you just have to solve it. What's kind of like the implementation of like the testing for that? Like testing isn't like giving out a test. Because like if it's your 5th thing that you're doing, it's going to be like taking forever. I imagine that you probably can't give like a bunch of problems, like 20 problems or something like that. Like how much do you take in, like by the time you take the test, do you need to be able to like realize that and be like, oh, okay, I know exactly.
There are problems in Cal 2 that will require all 5 methods to do the one problem. So like you start out and it's a basic U substitution, and then that integral turns into this integration by parts, and then that integration parts problem becomes a partial fraction decomposition problem. And that problem takes 35 minutes. And so you don't need many of those on a test. Like substitution is going to be kind of like, you know when you were learning what like the derivative of x to the n? You know, and you were like, now if I give you like x to the 7th, ask you for the derivative, you're like, no big deal, right? U subs is going to kind of become that to you. It's going to be like the very basic step we do. But you can't do any of the other stuff if you don't get this down, all right? So I don't know if I'm answering your question, but all right, so let's keep going here. I want to rewrite the problem. So this is going to become 1, right, over what? Square root of u. And Jace was asking about what are we going to do with that square root, right? I'm going to deal with it in a second. What does this become? 3 du. 3 du. Yeah, so this right here, the way we're going to deal with it is that this is something we actually don't mind doing now. Because we have square root of u, which is the same as u to what power? Negative 1/2. So I'm bringing it up now, right? And now I'm just going to use the power rule. So the antiderivative of this should be the 3 out there. I need to take this, n is negative 1/2, so I'm going to add 1 to it, which gives me 1/2. So this is 1 over 1/2 u to the 1/2 plus c. y'all understand where this came from? Okay, so I think you can see even here, like if you're struggling with this part, right? This is now just the very tail end of a problem. This is the way the entire pretty much section on integration works. If at any point you are foggy on anything, you will not be able to continue. Like you have to be good at all of it to get through it. Does that make sense? I'm not trying to intimidate you. You can do this. You can do it, but you will have to dedicate time to your math in a way that you have not done before. Very few people can just pick this up and just do it. I just throw them an integral and they're like, yeah, got it. You know, I've only maybe seen 2 students who just get it automatically. Okay, I'm not done. This is 6 square roots of u plus c. So flip, multiply, that's square root. And then now, final answer, 6 square roots of u, but u is x squared plus 3x minus 1 plus c. There's my answer. So if I take the derivative of this, I should get that. I won't check it. Ready for another one? So in section 5.5, which I believe I do have a homework assignment for that. Let me double check that. I believe I do. Oh, 5.3. Oh, no, not 5.3. You don't want 5.3. No, we're not doing 5.3. We're not doing 5.3. I'll give you some problems to do out of 5.5 for practice, okay? If anyone here takes me for Cal 2, which I don't know if I hope I'm not scaring you away, like 5.5, I think your homework assignment is pretty much, I think it's every problem, it's like 36 problems, every single one of them, like 1 through 36 all. And my homework solutions are me doing 1 through 36 all. So I don't ask you to do anything that I didn't do on my own, you know, so, but it's a lot of work. It's a lot of work. But in those problems, in the first 6, they tell you what the substitution is. So they kind of get you like going. They say, okay, use this u, and then after number 6, it's like you're on your own now. Okay, check this one out. Yes? If you start with the square root, are you always going to? Let me think about it while I'm writing this up here. I mean, it sounds right, but yeah, it's always going to be there in some form.
Yeah, or you just rewrite it a different way.
Yeah, it may be on the bottom or the top, but it should be there somewhere. Okay, how about this one? There are 2 ways to do this problem. I'm going to do it the first way. Okay, so here's one way I could do this problem. I could say, you know what? I'm not that scared of x plus 1 squared. So I'm just going to expand x plus 1 squared. Right? X plus 1 times x plus 1 is x squared plus 2x plus 1, right? And then I can take that x out front and distribute it through. Bam, bam, bam. And I get integral, I get x cubed plus 2x squared plus x. And now for that, can't I just do that each one at a time using the power rule? Can I? Can I do this, this, this? Yeah, because, you know, plus, plus, there's no division here, everything's clean. So I'm there, okay? Antiderivative is 1/4 x to the 4th plus 2/3 x cubed plus 1/2 x squared plus c. And I understand that maybe you're not comfortable with this yet, but I do trust that you understand what I'm doing here, right? Okay, so maybe it takes you a little longer to get these, that's fine. But we get to that, right? Okay, we're done. So if that's a way to do it and it wasn't that bad, then maybe I don't need to look at the other way, right? Until I come and change the problem and make that to the 20th power. Now can you use that same approach? Yeah. So I'd like for you to do that for the final. For bonus, please expand x plus 1 to the 20th power. Let's make that a bonus problem. You know what? Let's make it to the 200th power. Right? I really don't want you doing that. So I'll make that as big as until you submit to it. Does everyone submit? Does everyone submit? You're not going to try and expand that, right? Okay. So let's do that problem. This problem, no problem, because we can expand that, distribute through, we're done. Now, I'm going to try a substitution, because that's the only other thing I know right now, right? It's like I've got this toolbox, got my algebra drawers, my Cal 1 drawers, right? Got my Cal 2 drawers, I pull out my integral drawer, and all I've got there is like power rule and substitution. That's it. So, batter up. X plus 1. Okay, so x plus 1, if I choose that, what's its derivative? Because I'm supposed to see its derivative, right? So what would the derivative of this be? The derivative of this? Just 1, right? So this would be 1 like dx. Yeah? That's kind of weird though, right? Like this has not happened yet. Like we've always wanted this to be something that we can see and like match. Do y'all see that that's not really happening too much? But continue, okay? Continue, keep going. Let's see where this takes us. Right now, I can replace dx with du, right? I can replace x plus 1 with u, right? But there's one letter there that I have not accounted for, and that's the x. And you are not allowed to have u's and x's mixed together. This is, the whole thing's got to be switched over to u's. So what about this this x? What's x? If x plus 1 is u and dx is du, then what's x?
dux.
What's that?
dux.
dux?
Multiply both sides by x.
Both sides by x here?
Yeah.
Then that would be x dx, x du, right? I want everything to be u's, just u's, no x's mixed in at all. You might, from where? Isn't that an equation? Does it have x and u in it? Can you solve it for x? Just move 1 to the other side, right? So isn't u minus 1 equal to x? Isn't that the same? So we will be able to replace this, this, and this. And now we rewrite the integral. So x becomes u minus 1. Now I need that in parentheses, because that x is going to multiply times this. What's this? U to the 200th power. Well, crap, we haven't really solved that problem. Dx is du. Okay, so maybe your substitution was no good. Or was it? What was the problem with this original thing? None of us wanted to take x plus 1 and expand it, right? We were all like, no way. You did this substitution, and I agree this is what it is, but why is this better? Because this time it's u to the 200th, right? There's nothing to expand. And you can distribute the u through the parentheses, and there's no problem with that, right? So this becomes integral u to the 201st power minus u to the 200th power du. And what you've done is you've split it up now. Instead of having this product here, where you have this big thing to the 200th power that you didn't want to expand, you've somehow rewritten it in a way that it's just something minus something. You can take the antiderivatives of these each individually. I need to stop after this one. Okay, antiderivative of u to the 201st power is 1 over 202 u to the 202 and then minus 1 over 201, u to the 201, and then plus c. So that's your power rule. And this becomes 1 over 202 u, which was x plus 1, to the 202, minus 1 over 201 times x plus 1 to the 201 plus c. This is your antiderivative. This is an example of a substitution that doesn't seem like it's going to get you anywhere, and it winds up getting you there. So this is, again, like every example I've given you before this, I was asking you to look for something in its derivative, right? Something in its derivative, something in its derivative. Here, you just have to do something. Take the swing, hope for the best. In this case, it worked out. All right, let's talk about the final. Unless y'all just want to keep doing substitution, I don't mind doing substitution. You ready? All right, let's talk about this. Yes?
So, because I'm only listening to video, I was wondering, did you know that the titles all changed for your videos?
Like they're not titled anymore?
Yeah.
Yeah, that was, yeah, that's called laziness.
So I was looking through,
That's laziness on my
Oh,
part.
okay, no,
But they're in order, like the numbers are in order.
Well, because I was looking through all the videos and I didn't see the past.
I think I'm a little backlogged on what I need to upload. I was trying to upload videos the last 2 days from here, and they were just stuck.
Oh, okay.
Like they would start loading, and then something was wrong with my connection at my workstation. So tomorrow I'm going to come on campus, and I'm going to try and upload. I have your class and my Cal 3 and some other classes that I need to push some videos out. So they should all be there. I have to sort through them, but they should be there. All right, you ready? Okay, first, I have not written the test. Okay, so I'm going off of what I've gone back and I've looked at some of my old tests. And just to give you some flavor for what to expect. A test I gave a few years ago had 14 problems on it. So the first question, they were asked to find derivatives. So it was product rule, quotient rule, chain rule. But they also had to make sure they understood what the derivative of like 5 to the x was. Right? The derivative of 5 to the x is 5 to the x, natural log of 5. So these are on your formula sheet, but the idea is that there were some exponential derivatives in there. They had to know the derivative of log. There was one of those ones, problem number 2 was they had to find derivatives where you had x appearing both in the base and the exponent. We did problems like that. It's where you take natural log on both sides and you drop one function down and then you do your derivative. So that was called logarithmic differentiation. So number 1, standard differentiation. Every function out there is fair game. So make sure you bring your formula sheets. And then number 2 was logarithmic differentiation. And then number 3 was limits, L'Hopital. Number 4 was limits, L'Hopital. Number 5 was limits, L'Hopital. I really guess I wanted to do L'Hopital. I should be saying Bernoulli, right? 6 was another one. Yours won't be like this. I'm not going to give you like 5 or 6 L'Hopital problems. Now, within those L'Hopital problems, okay, what did I tell you on the last test that I would really emphasize when it comes to L'Hopital? What forms? Like 0 to the 0 or something like 1 to the infinity. Things like that are what I would expect to see if I'm going to give you a L'Hopital problem. Because if you do one of those, you have to convert it to the other form. So be prepared for that. Find the maximum and minimum, absolute max and min of a continuous function on a closed interval. I asked them to sketch a function. I don't think I'll ask you to sketch one. I gave them an optimization problem, a box problem where they had to figure out like the minimum area or something like that. And then at that point, I went to antiderivatives. So I asked them to do basically what we're doing here. There was no substitution on this test, so I guess I didn't get that far this semester. Okay, I'm just running through a couple of tests, all right, just so you can kind of get a flavor for what I've done in the past. I think with this, if I don't mention it here today, then I won't put it on the test, all right? So far, what I've mentioned, any of that could be on the test. Where the heck is that other one? Where'd it go? Oh, no. There we go. This is a more recent test. This one right here, the one I just talked about was about 8 years old. So here's one from a year ago. Okay, so we had a limit problem. Number 1 was a limit. Number 2, find the derivative of a function using the limit definition, which means limit h goes to 0, f of x plus h minus f of x all over h. So that's before we learned the shortcuts. You had to use that ugly formula and calculate the derivative. Let's see, number 3. Find the equation of a tangent line to a curve. Find the equation of a tangent line to a curve. Yeah, so that's where I give you a function, I give you a point, and I say go find the equation of the tangent line through it. So that's where you use that formula y minus y1 equals m times x minus x1. But you have to figure out the m from the derivative. Find a derivative. So this was just chain rule. Chain rule, quotient rule, product rule. Some L'Hopital. Find the absolute max and min of a function on a closed interval. So I think we can pretty much say that's going to be there. All right? I give you a function, closed interval. You go find the max and mins. And do it the right way, which means include your endpoints. Right? Do that, you remember? Okay, because I know on the last, test, people would do it, get the critical numbers, they forget about the endpoints. Or they would go do the up, down thing when it was closed interval to begin with. So, oh, here's one. I gave them a function, and I asked where it's going up and down, and I asked where it's concave up and concave down. So that's like, instead of asking them to sketch the whole thing, I just want to know where it was increasing, decreasing, concave up and concave down. So that's where you have to do your little number line, your test points. I like that problem. Let's plan on that. And then antiderivatives. Give them some antiderivatives. And there is a problem here that has substitution. 2 problems that had substitution in it. So to practice substitution, look at 5.5 in the book. And my solutions to those videos, I believe, are there. If they're not there, if you don't see the solution for 5.5, let me know, and I'll send the link for the class to my Cal 2 videos so you can get to it over there.
5.5 or 5.3?
No 5.3. No 5.3. We just didn't, yeah, we're not doing 5.3. We're doing 5.5. So what I think you should do from 5.5 is to try and do like the first, like the first 20 maybe. Because the first 6, they gave you the substitution.
On that test, was there at least one
What?
optimization?
There was not an optimization on that one. Are there any questions that you have about the test? Study guide? I thought that's what we were doing right now.
Chapter number, basically pretty much like from the 2.2 is all of them, right?
The problem I have with giving you all a review is that I'm afraid you're just going to focus all your attention on the review, and then I'll type up the exam and it won't look like the review, and then everyone complains that it wasn't like the review. So what happens then? I think it's, look, you're all going into Cal 2 pretty much. I mean, for the most part, unless the final is catastrophic, which my finals are not designed to make, like, to break you. It's just to make sure you're, like, ready for the next step. And the next step is a big step. Okay, so, you know, I think the best thing you can do is just take a look back at kind of the topics I've talked about. I want you to be able to take derivatives, right? I want you to be able to use L'Hopital's rule. I want you to know how to find max and mins. I want you to know some of this. This is more recent. Yeah, and I want you to learn how to study for a test without someone handing you a review. Because that is something that you need to get used to. I mean, you really do. I know it's hard to do that, but
For the substitution problems, are they going to be like this one where it's not that?
not obvious.
Yeah.
I'll stay within what the book does, and there are some problems like this. I mean, we just did this today, so I think I'm going to make it a pretty direct substitution. Like, you're going to see something and its derivative there. You know, I'll think about it a little more. If I have a better idea of what I really think I'm going to put on the test, I'll send an email out. So, you know, stand by. Maybe tomorrow in my office I'll be able to construct a good idea of what I'm going to do, and I'll send you a little topic summary of the things to focus. Yeah. Oh yeah, I'm also going to have to send out tomorrow a list of my office hours because they are different during finals week. Because I'm in places I'm normally not. At times I'm normally not. So yeah, I will be here next week, but it just won't be normal times. Yeah, say the final is on Thursday. Is it 12:30? Yeah, let me look at this. Yeah, hold on. Yeah, it is 12:30. It's 12:30. Yeah, is anyone going to have a problem getting here at 12:30? It's 12:30 to 3:15, so it's half an hour earlier than we normally meet. 12:30, yeah, to 3:15.
So it's
Yeah.
gonna be 3 hours, 2 hours.
2 hours, 45 minutes. Yep. All right, so make sure you eat, make sure you sleep before the test. Don't come in here like on 30 minutes of sleep and
Make sure you
no food.
send us the schedule.
Yeah, you need to be well fed and well rested. Your brain will work better that way.